In this video, we are going to look at the Gattermann-Koch reaction. We are going to look at the Gattermann-Koch reaction and the final product obtained in the Gattermann-Koch reaction. If you are new here, please take a second or two, then subscribe, like, and share the video. Now let's see the Gattermann-Koch reaction. It involves carbon monoxide reacting with hydrochloric acid, so that we get a product which is formal chloride. So this carbon monoxide is giving us this. So you realize carbon here is having 3 bonds instead of 4, so it will acquire a negative charge here, and oxygen is having 3 bonds instead of 2, so it will acquire a positive charge there. So we are reacting it with HCl with hydrochloric acid. So this carbon will now pick on this hydrogen so that it becomes stable with 4 bonds, so that we can have C bonded to hydrogen, then to 3 bonds bonded to oxygen, which is still positive, and these 3 bonds, 1 bond will come and neutralize the positive charge there, so that we can have carbon bonded with 2 bonds to oxygen, then to hydrogen here, and then it is having now 3 bonds again, so it will acquire a negative charge. And then you realize after picking hydrogen here, we are left with chloride ion, so plus chloride ion. So this chloride ion will come and get itself attached to carbon, so that we can have carbon bonded to chlorine, bonded to hydrogen, then bonded to oxygen. Now this becomes the formal chloride. This is now the Gattermann-Koch product. So we are going to use this Gattermann-Koch product to react it with benzene ring, so that we get the significance of the Gattermann-Koch reaction. So you need to know that at last we shall get the benzyl chloride, the benzaldehyde I mean. So we are going to react it with benzene ring. This is our benzene. We are reacting it with formal chloride H in presence of Lewis acid. So we are reacting benzene with formal chloride in presence of Lewis acid. The role of the Lewis acid is acting here as a catalyst. So the Lewis acid will pick on this chlorine, so this bond will open up, so that we can have benzene ring itself there, then plus CO and H. Now this chlorine is gone, so here we don't have another bond. So carbon is having 3 bonds, so it will now get itself attached in this benzene. So it will get itself attached in this benzene, making this bond to collapse. So this double bond of benzene will now collapse. So we shall have, after having this, so this chloride was picked by the Lewis acid, making the Lewis acid to be in this state. This is now our Lewis acid after picking on this chlorine. So after this bond opening up, we shall have benzene. This is our benzene now, with this group attached itself there with hydrogen. Then this is bonds there, and then benzene itself, initially it had its hydrogen there. Now after having it like this, so this carbon is having 1, 2, 3, and 4 bonds. So this is 1, 2, and 3, and 4 bonds. So this is stable, but you need to know that this benzene ring will strive to reinstate its aromaticity. Remember that this benzene is now not it's not an aromatic compound because it is lacking a double bond here. So this bond will collapse. This bond will collapse here, and then this hydrogen will combine with one chlorine here in this complex compound formed here, so that it forms hydrochloric acid. And before that, this hydrogen will collapse and reinstate the aromaticity. So we shall have benzene having regained its double bond here, and then this carbon with one oxygen then bonded to H, because this is gone. So we shall have this hydrogen combining with one chlorine here to form hydrochloric acid, then plus at last this the one chlorine gone shall then remain with 3 chlorine, so we shall have aluminium chloride 3. Now you realize that this was a Lewis acid used as a catalyst, and a catalyst at the end of the reaction you should be able to obtain, or rather to get, the catalyst back. And then you realize here that we have obtained our catalyst back. Now this is the benzyl. This is now the benzaldehyde. So this is the benzaldehyde obtained here. Now this becomes the significance of the Gattermann-Koch reaction, because it formed the formal chloride, then we used our formal chloride to react with benzene, then at last we arrived at the benzaldehyde.